Hi everyone, my name is Sebi. Today I wanted to give you an overview of a pipeline I created in Houdini that can generate procedural physics assets, as you can see, and that makes a very fun set of ragdolls. It's a system I've been building for my own games, and I will just give you a bit of a technical overview of how it all kind of works. Building something like this has taught me a lot of things about physics assets and digital characters in general. And I would like to explain a little bit what they are, what I kind of discovered along the way, and hopefully that can help you in your journey too. In summary, a physics asset is a collection of assets. It can contain bodies which are connected to a skeleton, the skeleton of your character, and they are bound by constraints. And that is mapped to the main mesh, and that's why you can see this ragdoll going like that. Before diving into a character's physics asset, I want to show and just explain a little bit a simpler physics body, right? This would be a simple shape like a sphere or a cube or a cylinder. In computer graphics, we represent these basic shapes with different meshes, which they are hidden. And in Unreal, if you pressed Alt-C, you can see the representation of the collision. The collision shape is what the physics engine is going to use to give interaction and presence in the world. Understanding shapes is really important. That's because depending on what shapes we are using, we will have more or less compute expense. For example, a sphere is the cheapest shape to compute because it only has one component declared, which is the radius. A capsule technically has two components, which is one radius and a length, and the length defines the distance between two spheres. They have the same uniform value, so you can actually store the radius once, and you don't need to compute three components. A tapered capsule is where a capsule has two spheres, but they have different radiuses, so then you need three components. And boxes are the most expensive of the basic shapes because they need the three components to be defined. These bounds in order to have the depth, the length, and the height. As you've seen at the beginning of the video, a character is pretty much more complex than a simple shape, and in this example I will show you why. And it's all due to the constraints, but fundamentally to the hierarchy that constructs the combinations and the relationships between bodies. In my left I have three spheres, and they are independent from each other, so they are just interacting in the world, but they don't have any connection. And as you can see, this one is a chain, and the chain basically will set a specific connection between spheres. And the way that we connect them is with constraints. There are generally two types of constraints. We're going to talk about linear constraints and angular constraints. A linear constraint would be, for example, this orange one. In terms of imagine this is a body, right? I'm going to try to move it. So if this body is going to move, I'm not going to allow it to get close to the parent, right? It means that it's going to be stuck at this specific linear distance. You can set it to locked, free, or limited, and then you can allow it to have movement relative to the parent. An angular constraint, on the other hand, would be how much it can rotate in the axis from its parent, right? Depending on its relative rotation. Something that's very interesting with hierarchies is the inheritance of transformation and rotation. And here is the same exact chains that we just saw, but they have more children. So the behavior of the constraint gets really accentuated. You can see here in the left, it becomes a much more stiff object because they are all set at 15 degrees. So it becomes a bit like a wobbly worm, right? That's how this hierarchy is built. It's a linear hierarchy, but it's still hierarchy. And this one is a lot more loose, although it has the same amount of cubes. I don't want to lose it, but kind of you can see that it behaves a lot more loose. When it comes to characters, usually their hierarchy compared to this chain that we just saw, it's a little bit more complex, right? They have branches and they have different dependencies. This is a humanoid, it's a skeleton from Electra, and you can see that if I rotate the fingers, all of them will inherit that rotation. Technically, a character is really like a chain of transformations that get inherited with each other, and that is what will be useful for our bodies in order to be physically accurate. The way this pipeline mainly works is that I'm using the input character skin and its skeleton to compute all these bodies. It can also then compute the hierarchies. You can set the shapes. It automatically calculates thicknesses, lengths, amounts, etc. Right? And you can parametrically change all those settings together. There are a lot of benefits to compute the physics assets in Houdini. It allows me to do it procedurally rather than manually in Unreal Engine. And I have a lot more control of how my bodies or my constraints behave. For example, one of my favorite settings is the padding. If you work with physics assets before, you know that when bodies intersect, right? Let me show you if I put the capsules. This combination of bodies right now, if you don't specify that they shouldn't collide with each other, it will create a very funky physics simulation where it will basically explode. And being able to adjust on the fly, if I want specific types of shapes like boxes, I can see and adjust and make sure that they don't intersect with each other. The padding is great because it allows me to add distance between bodies. In this case, you can see that now these two bodies are intersecting. And to simplify shapes and to reduce complexity, you can add more padding, and now you can see that here there is like one intersection less. You can also adjust the shape offset. You can see that you can make it a bit thinner, a bit thicker, and it's nice to compare it with the input mesh so that you can see if it's actually covering your character. Another great feature is that you can resample the actual bodies, and this makes it so that you can reduce the amount of bodies that your physics asset will have, which increases by a lot the performance. Of course, you reduce the quality at which they will behave, but you can add and adjust that as well. You can also add lift bodies, and those are the ones that live at the edges of your skeleton. And here, for example, you can see I can add the head, and it will automatically find that bone and adjust it a bit. It uses a relative distance from the mesh, so it's usually quite accurate already. I'm experimenting with something I call modifiers. I'm going to take this template of the character out. And the idea here is to add rules, right? With these rules, I can check how many shapes a body has by count, or I can check if there is a group into it. And then I can modify that specific body by doing different actions. For example, this rule is going to use a method of counting, and we can say that if it's greater or equal than a specific number, we are going to reshape the actual body. So here I say that if the shape count is greater or equal 0, we replace it by a sphere, right? This kind of doesn't make sense because everything gets replaced. But if I put a 3, for example, you will see that now only the ones that have 3 or more bodies are targeted. And now I can change that specific body to change and use this rule. This is a bit still a work in progress, but my idea is to have different actions. So for example, a replace action would be to replace the body with a different shape. I would like to have a prune. So for example, you can just remove it altogether, or we could have like a reducing. And reducing the body, you can see that it will replace those 3 by just 1. This is a pretty complicated process because you have to take a lot into consideration, and you can see here already that you are losing a lot of area. So I have to figure out how to calculate those things, but I really like this approach where through rules you can simplify a lot the amount of physics bodies. You can see now I have 50. If I remove this rule, I go up to 62, which for a video game is quite important to have those controls and be able to have a bit more agency over how your assets are going to be. Once you are happy with how this works, or you have a specific profile that you want to export, you need to compute the constraints or not. Doesn't really matter, but if you want it to stay together, you probably won't. And then you can set up settings, right? And here is like a process that I can set profiles, and it's a little bit too complicated right now, but what this allows me to do is to group certain bodies with a specific set of settings, right? This is something that Unreal is a little bit more tricky to do. I'm still not fully, it's not fully done yet, but I have a few tests where I can actually set specific bodies with specific limits, and it parameterizes the process, which is quite complicated, which is the physics asset creation. And this stripes it down to all these blocks, and it's a lot more affordable and approachable to do. And then you can export the asset. Once I'm happy with the way the bodies and the constraints or everything is looking, I can just export it. The asset is exported as a simple JSON file, which can be a lot more modular and dynamic than just doing it specifically in Unreal. One day I would like to implement this in Godot, so then I have a lot more space to do that once you have your output readable and actually open. And in Unreal, having the specific mesh that is exported, the character, I can just toggle this import physics asset. It's a custom plugin to read the JSON file, and then it generates the physics asset. Once I drop it here, you can visualize that it does look quite similar. So let's check the comparison. It's actually should be the same. And if I simulate, it already works. What I really like from using Houdini to generate these physics assets is that I can still change a lot of things, and importing and exporting is really fast as it is just reading a JSON file, and the computing is all outsourced in Houdini. So here I could just change the shapes to capsules, and maybe I will make the shape offset a little bit smaller. It's just a little cramped right now. So I'll make it a bit smaller, right? And if I export and go back to Unreal, I can just literally re-import the physics asset, and it's really fast to export and import. As I mentioned before, you can change a lot of the settings. For example, something that it's very interesting is to be able to change the swing limits without having to edit the physics asset itself. Usually you would open the physics asset, you would need to select all of these, which already takes quite a long time to compute. And if you select each individual constraint that is computed, you can change here the way that the limits are going to behave. I outsource that completely. I don't have to do it in Unreal anymore. And I can create this network which will control the output in a JSON file. For example, here I like to put, for example, the limits very low, and this will create a very stiff type of physics. And here, if I re-import it again, we can see how it looks. And you see that now the puppet is very stiff because we don't allow the limits to move a lot, which is really cool. Talking about character quantities, this for me was very important to develop because I'm making a procedural character game environment. This is pretty insane. And I do need to process a lot of these physics assets, and they need to be data-driven, right? And here I have a character processor that I can just select and be able to debug quite a few things. I can check different types of physics assets with different settings, with different characters, and it all kind of gets computed through Houdini, which is a better place, in my opinion, to do this type of computations. Right now, a lot of these examples are placeholders, so it's not really my own designs, but it works for me to develop this tool, which is going to be quite important for the type of work I want to do. Look at that. This character processor allows me to make a lot of variations in terms of physics assets and their settings, and it helps me to debug because it is really a complicated thing to manage and to code. For example, here I have a comparison between the red and the green characters. The difference is that the red one is using the generate bodies, the default function from Unreal. And you can compare a little bit how much extra space it takes compared to the one that I can bake, right? Which is a lot more accurate. You can see, for example, these fins, something I do not really want to do manually, but this is very easy in Houdini to automate. If you would compare this crazy squid over here, it's pretty crazy, right? Like you would need to do like a lot of manual adjustment, and this can kind of work really well. The same goes for humanoids. Humanoids, for example, this one, the input directly makes like a pretty default capsule for the legs, and in the case of my own bake, it can make even the fingers, right? So it's a little bit more detailed. It is not only on the definition of the bodies, but it's also on the behavior. You will see that it's a lot more cohesive. The red ones kind of clip with each other, as you can see, and this leg. These tools I made, it makes it a lot easier to combine that, and it makes it a lot more grounded to the world, which is very, very interesting. Of course, these are not cheap to compute, but as a test, it works pretty well. It's pretty fun to play with as well. You can basically interact with them quite funly. This is another advantage of using PDG with Houdini and exporting and generating physics assets in Houdini is that you can create a lot more variations, and you can actually see what works and what doesn't work so well. Here you have like a lot of different shapes. For example, the tapered is pretty expensive, but works well. And you can see how kind of it behaves with those settings, right? The spheres actually work really well. I like them quite a lot, but it's a nice way for me to figure out, debug it a little bit, and play with that, right? I just made this simple blueprint as I showed. It's quite simple, and I can select the ones I want. I already have set some of the settings. And here I could change the characters. I could use the capybara, for example, and play, and I'll just have the same result. I can play with them a little bit, which is pretty fun. It does save a lot of time. For example, I have this prototype called a Rambo, and it's a pretty strange, let me show. It's a pretty strange shape, right? Maybe you need to make some space here, but this would be quite difficult to set up in terms of physics assets, right? There's like so many bones, a lot of different, yeah, things to change and set up. And I think this is where approach like this makes a lot more sense, where you use the character itself and a more data-driven approach, so you can create and generate, as you can see, like really realistic physics, right? And it's something that I kind of learned along the way of this project. Is Real engines physics are really good. It's just that you need good physics assets, otherwise they just don't shine as they could, right? And here you can see it's a character I made myself. It's pretty weird, but because of this system, this pipeline I made, it's a lot more grounded to the world. You can see it kind of behaves a lot nicer with everything around it, and I think it's pretty fun to really excited to see where this can go. All right, I think this is it for me, this video. This has been a pretty long research I've been doing for quite a lot of time. I just didn't have enough time to sit down and actually develop all these things, but finally I had a bit of time, so I was able to work on that, which has been really fun, to be honest, and I'm very excited to see where it can go. This tool or this pipeline is not for sale at the moment, but I'm open for contact. If you are interested, you can reach me out. I'll leave a link on my website. You can just send me an email and we can see from there. But yeah, hopefully you could learn something, and this was like an interesting breakdown of something that I haven't seen being made, and I'm very excited to see all the things I'm going to do with this. So yeah, have a good day. See you.